Yeah, good afternoon all. Right. Okay. So this week is tutorial 4. Okay. So this tutorial 4 is for topic wastewater generation, topic 6, and also topic 7, unit operation plus the conventional treatment system. Right. So you can listen for me. Yeah. All right. Okay. So there are four calculation type of the question here. Okay. So so for this topic, topic 7 and topic 6, right, is somehow has a little bit with those what you have learned in earlier. Like for example, this BOD and then also solid, right? Okay. So these are the water quality parameter that you have learned uh, in the earlier topic by Dr. Gan, the water quality, right? Okay. By the calculation for this BOD loading and the solid loading, right? And also after that, when you come to topic 7, the unit operation, okay, Dr. Khoo also explain to you some of the physical treatment, okay, right? And these are also a formula you encounter before overflow, which is the flow divided by the surface area, and also the detention time, okay, volume divided by the flow, okay, right? So these are all very general formula that I have shown you before during the physical treatment, right? So uh, during my lecture last time, the physical treatment, I explained to you the theory for a few physical process, right? Okay, but now this topic 7 by Dr. Kuwan is mainly uh, and also involve some design criteria. The design criteria, that means based on the daily wastewater flow, okay, then let's say you already asked to design the clarifier, okay, it could be different shape, right? The number of clarifier required, or maybe in different dimension, right? So the design, and this design criteria have certain guideline to refer to, yeah, refer to, okay. So this is topic 7, right? Okay, so now we start with question 1. Okay, uh, the the industrial wastewater. So this is the industrial wastewater. Okay, has a total flow of 180 meter cube per day. Mean in one day, right? They produce this volume. Okay, and the wastewater consists of BOD and suspended solid with the concentration given, right? Okay, so this is the 400 mg per liter BOD and 480 mg per liter suspended solid, right? Uh, okay, so mean that, right? So this is the industrial waste with this daily flow 180 meter cube per day, right? Okay, so you enter into the wastewater treatment plant, right? Okay, so the BOD, the wastewater contain BOD and the suspended solid, right? Okay, so both BOD and suspended solid, the condensation is known, is given already, okay, right? Uh, okay, so you're asked to calculate the daily BOD and the suspended solid loading, right? So meaning that, right, so we don't look at this solution yet lah. Let's say we focus on the question here. Okay, so if you know the concentration of BOD, okay, meaning that 1 liter it contains 400 milligram BOD, okay, 1 liter wastewater, right? And now the daily wastewater is this volume. That means the daily wastewater is 180 meter cube. Okay, So if this volume multiplied with the concentration, this is the amount of BOD in one whole day lah. So which is the daily BOD loading. Right? Okay. So it's very simple. Just multiply these two. But the only thing that you have to take note is the unit conversion lah. Because this volume in meter cube, but this volume is in liter. So you must take note of this conversion. Right? Right. So now we look at this solution. Right. So the first two terms, okay, so this is the BOD concentration, okay, multiply with this second term. This second term here is actually the conversion factor from liter to meter cube. Okay, liter to meter cube, right? So after this, right, meaning that this is the BOD concentration in milligram per meter cube. Okay, milligram per meter cube after conversion, right? Then multiply with this daily flow, okay, daily flow. So you cancel this meter cube. So this whole thing become the BOD loading per day. It means the daily BOD loading, the daily BOD load into this wastewater treatment plant. Okay, in the unit of milligram per day. That means milligram BOD in one day. Right, okay, the loading. Okay. Then this milligram is very small. Then you can convert to kg. Okay, so the last term here is the conversion unit from mg to kg. And you see, so that your answer is report in kg. So the BOD load 72 kg in one day. Okay, per day. Right. Okay. So if you expect in milligram, also correct. Okay, but there are many zero at the back lah. Okay, because it's milligram. So it's better to convert to kg. Right. The same goes for this suspended solid loading. Okay, so this is the suspended solid concentration given in the industrial wastewater. So multiply the second term. So now you have the suspended solid concentration in the unit of milligram per meter cube. Okay, mg per meter cube. Then multiply with this third term, the daily flow. And now this whole thing is become the suspended solid loading in one day in mg per day. And after unit conversion to kg, so this is the answer reported lah, 86.4 kg. Okay, right? Right. So meaning based on this BOD and the suspended solid concentration in 1 liter, okay, and with this the daily wastewater volume that produced, okay, so this is the amount of the BOD and the suspended solid load into the wastewater treatment plant. Okay, so this is the amount lah, 72 kg and 86.4 kg. Alright, okay. Any question for anything you want to ask for this question one? Right, so I continue. Right, question 2. Okay, so question 2 is similar to question 1, but this is for the domestic wastewater. Okay, the domestic wastewater is the wastewater that produced from the residential area. Okay, so the wastewater is can be considered cleaner, okay, less toxic, less pollutant, okay, compared to the industrial wastewater, right? Because this is from the just like residential area, the shop, right? It's not from factory. It's not based on the manufacturing process. Okay, the question based on the sewage design guidelines practicing in Malaysia. Okay, so the sewage design. Estimate the daily domestic wastewater flow. Yeah, okay, so you need to estimate how much, what is the daily domestic wastewater produced every day, and then after that, to calculate the weight of the daily BOD and SS. Means calculate this BOD and SS loading, right? Okay, produced by a mixed development consists of 200 double story and 2,000 meter square area of commercial lot. Right, so this is an area, one small town lah. Let's say we have 200 double story, and also the short lot. So the short lot is not counted as how many units, but it's by the area occupied by the short lot lah. So it's 2,000 meters square. Okay, right. So every day there are activity from these two, double story and the commercial lot, right? And this based on the number of population, right? Okay, the higher the number of population, the more activity and more wastewater will produce, right? Okay, so all the wastewater that produce, okay, will be channeled into one centralized wastewater treatment plant, right? Okay, so how much wastewater produced here, how much is flow, you are asked to estimate this Q. That's the daily flow, how much produced daily flow, right? With this daily flow, then you calculate the BOD and the suspended storage loading into this wastewater treatment plant, right? Okay, right. So how much daily flow of the wastewater produced, it depends on, as I mentioned, the population, the number of people staying in this double story, and also those people making use of the service in this commercial lot, right? Okay, so how to get this population? Okay, so it's based on this PE, and this PE you can refer to your note. This table. This is only refer to Malaysia guideline. Okay, so it depends on what kind of development. Okay, so let's say for residential, it refer to 5 population per house. Okay, because somehow, let's say family, they have less population, but for those, if the house is rent to the student, they have more population, right? So, okay, so we stick to 5 PE per house. Okay, so 5 PE per house. So meaning now, this is we have 200 double story times 5 lah. So this is the PE for the double story. Okay, then for the commercial lot is 3 PE per 100 meters square. 3 PE, right, per 100. So we have 2,000 meters square. So this is the one PE for commercial lot. Right, so these two total up, we have 1060. 1060 PE. Okay, so we have this 1060 population, right? Okay, who are using the water for activity, for cleaning, for cooking, and eventually produce the wastewater. Okay, that will be centralized into this wastewater treatment plant. Right, so with this PE, okay, we can calculate the flow, this Q. Okay, follow this formula. Okay, 0.225 multiplied with the PE. Okay, right, so multiply this PE, so you get this flow lah. So the Q here is the daily flow is 238.5 meter cube. So that means from these two development, right, this is the amount of daily domestic wastewater produced from these two development. Right, okay. Right, so why this 225? Okay, for this Q. Okay, so 225 is actually also the formulation guideline. Okay, so you can refer to this table. Right, okay, so different country different value, right? So for Malaysia, right, the flow is, it means for every population, each population will produce 225 liter, okay, wastewater per day. Okay, or in terms of meter cube is either 225 liter or 0.225 meter cube, right? Okay, so this is the okay, that's a fixed value, typical value for Malaysia. Okay, right, so that's why we have this equation to calculate the flow, right? Okay, so after the flow Q, then we can calculate the loading, the BOD and SS, right? Okay, okay. BOD and SS is two very common water quality parameters to assess the quality or the cleanliness of the water lah. Okay, right? Because the SS from this suspended solid, we are able to assess the turbidity of the water, the clarity of the water. Okay, and also and then for this BOD, we can roughly assess the organic waste in the water, right? Okay, so these two is a very important parameter. Okay? Right. Okay. So alright. So to calculate loading, we make use this formula. Okay, it's the flow, mean this flow lah, the daily flow multiplied with the BOD condensation or the SS condensation divided by 1000. Okay, so this is the condensation of the BOD multiplied with this daily flow divided by 1000. So you get this BOD loading. Okay, the same go for this suspended solid loading. Right. Okay, so this formula actually the same formula lah. This one, the both. Okay, right. Okay, you might ask me why we have to divide this 1000. Okay, and how this 1000 come from, right? Okay, so this 1000 is, okay, so if let's say for a clearer understanding, you refer to this formula just now I explained one. Okay, right, because from this formula, right, we have two unit conversion, which is this one from liter to meter cube, and then the other one is from mg to kg. Okay, right, so these two unit conversion, is it, after you cancel off the 30 here and 30 down here, so you still left per 1000. So that's how this 1000 come from. Okay, so this 1000 is from these two unit conversion. Okay, yeah. Okay, so you can straight away apply this formula out, or else you can do this also. Same thing, same thing. Right, so this is the daily BOD and the suspended solid. Okay, load into the wastewater treatment plant. Okay, based on this daily flow, lah. Okay, so if your if it's one day, if more wastewater is produced in one day, or the higher the daily flow, then the higher the BOD loading. Okay, the higher the BOD or the higher the suspended solid loading. Right. Okay, this is question 2. Right. So question 2, do you have any question? Anything you want to clarify for this question 2? Maybe you find out something which is you are curious about something for question 2. Very clear. No question. If you have no question, but I have a question to ask you. Right. Okay. So for this question 2, you see, right? Basically you are asked to calculate the BOD loading and the suspended solid loading into the wastewater treatment plant, just like question 1 lah. Right? Okay. And the information that given to you is only this mixed development, meaning that you were only told 200 double solid, and then 2,000 meter square area for the commercial lot. Only these two, right? Okay, and then from these two, okay, you have to calculate the PE first, and after that the Q, the daily flow, right? The daily flow here is the total wastewater produced in one day lah, one day, right? Okay, and lastly, for this BOD loading and the suspended solid loading, okay, the calculation here, right? Okay, so you need the information on this BOD condensation and also the suspended solid condensation. Just like question 1, right? Is it mentioned in the question? This is the BOD condensation. This is the suspended solid condensation, right? Okay, but in domestic, in the question here, no info at all. Okay, then now why do you use these two value? Why do you use these two value? Any idea? Right. Okay. So these two value, the domestic wastewater, right, as I mentioned, if compared to industrial wastewater, is quite is a bit more stable kind of wastewater and also less toxic. Okay. It's different for industrial waste. Industrial wastewater, right, it depends on what kind of manufacturing process, right? Okay. Different manufacturing process have different wastewater characteristics. Okay, and the BOD and the suspended solid also very high, extremely high in the wastewater for industrial wastewater. Okay, so for domestic wastewater, we also refer to this guideline. Okay, for Malaysia, the XX we stick to this concentration and the BOD we stick to 250. Okay, because actually the government fixed already. The condensation fixed already. It means we fix the condensation. Okay, alright, and the condensation is fixed, but the loading is not fixed. Okay, the loading is depend on your Q. Is it? The loading here depend on your flow here, the Q. So if more wastewater is produced, then the higher the BOD or AS loading. Okay, the condensation is fixed, but this the Q here is not fixed, right? Okay, the Q here it depend on this PE, right? So once the PE change, if you have different development, then the PE change, then the Q also follow change, and this will affect the BOD and the AS loading, right? Okay, question 2. Okay, question 3. Right. Okay, so question 3 is it? So let's say if you are a wastewater engineer, okay, and also based on the daily wastewater flow, okay, if you know the Q daily wastewater flow, then let's say we need to design the clarifier, okay, the tank for the physical treatment or biological treatment, the clarifier, okay. So after you design it, okay, so the design it can be different shape, different size, and in how many unit, mean the number of unit, right? Okay. So after the design, and your job is not end yet, right? So you still have to check, have to check to make sure your design is correct. It means the design is appropriate to the daily flow, the Q. Okay, right? Okay, because the Q, the daily flow, right? The wastewater from the manufacturing process is fixed already, right? Unless we can control the production, okay? Okay, the production capacity, then only we can control the daily flow, right? Okay, so that's why as an engineer, we can't control, we have no right to control the daily flow. but so we have to fix it. Okay, so what we can do is we design the tank based on the daily flow, right? Okay, and after design, we have to make sure whether it's correct or not correct. Then that one we can refer to this EPA standard. Okay, so EPA standard, you have this table, right? From your lecture note, right? So this is the this is actually for sedimentation tank. Okay, sedimentation tank, right? Okay, and for this clarifier, we have also like primary or the secondary. It means okay, the after physical process, the clarifier, or after uh, the biological process clarifier different. Huh? Okay, so this is the uh, guideline for overflow rate. Okay, right. And this is the water depth, and this well loading, right? So we have to make sure that the value that you calculate must fall within this range. Then your design is okay. Yeah? So let's look at the question. Question 3. Right. So a treatment plant operate with two clarifier. Okay. And this clarifier actually is the circular type because we are given the diameter circular type. Okay. So we have two. Okay. Two unit with 45 feet in diameter. Right. Okay. So the wastewater flow in. Right. The flow of the water is not constant 24 hours in a day. Okay, sometimes will be low, sometimes high. Maybe at night time the production slow down, then your flow will reduce lah. Okay, but in daytime the production speed up, then maybe your flow is high. Okay, so sometimes it's high, sometimes it's low. Right, so we have so to characterize the flow we have two. One is the average flow. That means from high and low, so we have average value, average flow, and then the other one is the peak flow. Peak flow means during the 24 hours in one day, right? That's the highest flow. So that one is peak flow. Okay. So now the wastewater here, okay, enter into these two clarifier, okay, with the flow, okay, the two different flow. One is the average flow of 3.4. Okay. This mg here is not milligram. This mg here is million gallon. 3.4 million gallon day. Okay. And then for the highest flow, the peak flow is 6.4 million gallon day. Right. Okay. So we have two different flow. Right. So now, calculate the overflow rate. Okay. Right. Then you compare with this the EPA standard to check whether your design is adequate or not. Right. Okay. Alright, so now, okay, so this is the formula for overflow. Flow over surface area. Okay, flow over surface area. And then for flow, we have two different flow. One is the average flow, and then the one is the peak flow. Okay, yeah, peak flow. So that's why due to these two different flow, right, then we have two overflow. So we have overflow at average value, and then we have the overflow at peak value. So you have to calculate both. Okay. Okay. So we start with this surface area first. A. Okay. So for this circular clarifier, the surface area is pi r squared. R is the radius pi r squared. Radius. So radius is the diameter divided by 2. Okay. So pi r squared or pi d squared over 4. Right. Okay. So it's pi d squared over 4 times 2 unit. So this is the total surface area for the two circular tanks. Right? Okay. Then now we calculate the overflow. Flow over surface area. Okay. So this is the average flow over this surface area. Okay. 3.4 million gallon. So million is 10 to the power of 6 million. So that means this is 3.4. This is already million gallon. This is gallon per day. Okay, per day. Gallon day. And this is the area feet squared. Okay, so your overflow at average is 1,000 plus gallon per day per feet squared. Right. And then the other one is the overflow at peak. Okay, so this the peak is 6.4 million gallon day. Okay, so 6.4 million gallon day divided by this surface area, so you have 2,000 plus gallon per day per feet squared. Right, so these two value is fall under this range. Okay, this you have to count. This is the one for average flow. This one for peak flow. Okay, they fall under within the range. So meaning that the design of this two circular tank with this dimension of 45 feet diameter is suitable for this wastewater lah, for this daily flow, for this queue daily flow, right? Okay, right. So now the next question is, can one unit remove from service at every flow? Okay, so let's say now, so after maybe sometime after uh, a duration of operation, one of the tank is being shut down. Let's say the tank is being shut down for maintenance. Okay, shut down for maintenance lah. Right? Okay, so we left only one tank. Okay, so the daily flow now have no choice and have only enter into one tank only. Okay, so all this 3.4 and 3.5, right, flow, right, have to enter into only one tank. Right. So now the question is, okay, so if you have one tank now, if the design still okay or not okay, right? Okay, so we just redo a calculation, the same calculation, but for only one tank. Okay, right, tank. Okay, so the surface area for one tank, water volume, what mean by this water volume? Right. Okay, surface area for one tank. Okay, right. So that means one tank by half lah, by d square divided by 4 lah. Right. So this is the volume of solid surface area for one tank. All right. Then after that, we do the same thing, calculate the overflow at average value and overflow at peak value for only one tank. Okay, only one tank. All right, okay, then, okay, now we see, now we are only one tank. All the flow focus into one tank. Okay, so you can see here, the value is double. Okay, so now the overflow at average is already double. Is it from this 1,000 plus now is 2,000 plus. Okay, the same for overflow at peak, also double. And these two value is actually out of this range, out of the range already. Okay, right? So meaning that it's okay, lor. Right? So not okay. So meaning that, right? Based on this daily flow, either 3.4 or the peak flow of 6.4, right? Okay, right? So one circular tank with this diameter is not enough to cook this volume. It's not enough to cook this volume. Okay, so meaning that the design out already. Okay, so this is how you check whether the design is okay or not okay. Right? Like in this case, right, what you can do is, okay, right, what you can do is, if let's say you want, you need back the two tank, or if let's say you stick to one circular tank, then you can increase the size. Okay, you can increase the size. Right? So this is the explanation here. Right. Right, okay. So if let's say we have two circular clarifier, okay, so this is the total area. uh, uh, the overflow rate will be this value 1000 plus. The overflow at peak flow is 2000 plus, and these two values are within this range. So the design is appropriate. That means it's suitable for this steady flow. So if one of the unit is removed, let's say for maintenance, okay, so all the daily flow will focus into only one clarifier, okay. And now you can see the value is double. This is an double, okay. And compared to the EPS standard, they are out of range already. They are out of range lah, right? So out of range means maybe right, some of the suspended solid is not able to have, is not able to settle to the bottom of clarifier, okay, and it will escape to the next process, exit into the next process, right? So we have to look into the design, okay, to solve the problem lah. Right. So any question for this question 3? Right. So if no, we continue to question 4. Right. Question 4 also the same kind of question, okay, but the clarifier here has different shape. This is the rectangular. So we have eight rectangular clarifier, okay. For either rectangular or square one, right? So the dimension of the length, the width, and the depth must be given. Okay. So this is the 18 feet width, 100 feet length, with the 16 feet the water depth. Okay. These are all dimensions of the clarifier. Okay. And each and this is the real length for each clarifier. Okay. 108 feet for each one. Okay. So now mean that we have a lot. We have 8 rectangular clarifier. Right. So let's say 8 lah. 8 wastewater comes in. Okay. And the wastewater flow, the Q is, again, we have the, this is the average flow of 6 milligallon day. Then for the peak flow, the peak flow is 25 million gallon day. So we have two flow. One is the average value, one is the highest flow, right? Okay, so we have to calculate lah. Okay, the design here, the design of the clarifier must be able to cope the average flow and also the peak flow both, right? Okay, so calculate the overflow rate, then time, and the wear loading. Okay, then later to check whether the clarifier is adequately time for the flow or not. Right, okay, so the overflow, again, this formula, okay, remember this formula, right? Okay, so we calculate the total area, the surface area first. Okay, so the surface area for the rectangular tank is the 18 times 100, right? And then because we have 8 unit, 8 clarifiers, so multiply 8, so this is the total surface area lah. The total surface area for the 8 clarifier, right? Then the total area multiplied with this, the 16, that, so you have this volume in feet, cubic feet, right? Okay. And then this is also a volume. This is also a volume, but in gallon. Okay. After the unit conversion from cubic feet to gallon, right? Okay. Okay. So we calculate this because later we need to use this value, right? Right. Then the wear length. The total wear length is 108 times 8, so it's 864 feet. This is wavelength. Huh? All right, so we have all this the area already. So now we calculate. Okay, overflow rate. Okay, for this overflow, two value, overflow as average and overflow at peak. Okay, all right, the same method. So the Q, so this is the average flow over the area. Okay, and this is the one, the peak flow over the area. So you get these two. One is 400 plus, and then the other one is the 1,700 plus, right? Okay, right. And this two overflow value is lower than out of the range, mean below 800 and also below this 2,000. Right, that means it's not okay lah. Right, so I would say that right, the design here is too much already. That means you design either too many tanks, okay, or the size is too big, okay, because the overflow at average and peak only this gallon per day per feet square, right? So that means what you can do is you can either redesign by reducing the number of clarifier here, or you can redesign by reducing the size. That means you can reduce the length and the width, right? Okay, why? Because this overflow is controlled by this surface area. Okay, the flow we can't is out of our control because it is based on the manufacturing, the production. Okay, right. So we only can play design can only play without this A lah. Okay, so the A here means the total surface area. You can either change the dimension, make a smaller tank, or you can reduce the number. Okay, the number, right? So how small you can reduce, or how many tank you can remove, right? So it's still a question lah, right? So for example, like if let's say you remove 3 tank, right? It becomes only 5 tank, right? You should redo this surface area and then we calculate this overflow, okay, to see whether this value fall within the range or not. Okay, we have to adjust, we have to redesign and adjust until this overflow, right, at average and at peak, right, must within the range, must fall within the range. Okay, then the next one is the time, detention time. Right, detention time is calculated by volume overflow. Means the volume of the clarifier divided by the flow. Right, okay. Because the flow here, this is a gallon. This is gallon, this is gallon per day. Gallon per day. Right. So the volume here must be gallon lah. Gallon. Okay. That's why we have this unit conversion now from cubic feet to gallon. So that we can cancel the gallon. Right? Okay. So the detention time is 6.89. Okay. So after you divide this volume with the flow, then the value you obtain is in the unit of per day. Per day. Okay. Right. Only when you multiply the answer with 24, then you get the answer in hours. Right. One day, 24 hours. Right. Okay. Right. So detention time is just a time of the solid retained in the clarifier. Right. Okay. And we cannot base on this time to conclude whether the design is okay or not okay. No. Okay. Detention time is only calculated based on this volume and the Q. Right. Okay. So once you resize or you change any design, any dimension, right, your volume here will change, then the time here will change accordingly. Right? Yes, then the last one is the wear loading. right? The wear loading is the flow divided by the wear length. Flow divided by length here. Okay. So we have the wear loading at average flow and also the wear loading at peak flow lah. Again, two. Okay. So it's straightforward, right? So just this is the average flow, 6 million gallon day divided by this the wear length. So your wear loading is 7,000 gallon per day per feet. Okay, and this value is less than 10,000, 10K. Okay, so it's not okay. Okay, the wear loading at peak flow is 29,000 gallon per day per feet. Okay, but this value now is within the range, right? Okay, so all right, so now how about your design? Is it okay or not okay? Not okay. Either one, if one okay, one not okay, still not okay. Okay. You have to make sure that all the design, let's say this overflow, right, or this wear loading, right, okay, right. So overflow average must fall within this range. Both you have to check both for average flow and the peak flow must fall within the range. Okay. The same for this wear loading. Right. So you have to resize your or redesign your clarifier to make sure both wear loading at average and at peak must fall within the range. Okay. Right. So now it's sufficient, but inappropriate. Right. Need to redesign the number. Okay. Maybe you can reduce the number of clarifier or you can make into a smaller size. Okay. The size of the clarifier. Okay. Right. So that's all for it. Tutorial 4. You have any questions? Make sure you scan your attendance. Okay. The bar list will be generated after 5 days. Okay. So any question you want to ask? If no, then I have to stop here. Okay, because the next class is the physical class. I have to go to the tutorial room. So we stop here and then I will meet you again for the last tutorial on week 7. Okay, week 7. Okay, and don't forget next week is the submission due for the assignment. Okay, all right, thank you.